Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 2 for basics of unsupervised machine learning. Third one is document clustering in text mining. So a company or organization has a large collection of documents, articles or customer feedback that needs to be organized automatically into topics for better management or analysis. Application by converting text document into numerical features. Again, this comes, remember the basics, previous basics. K-means clustering can group similar documents into clusters. For example, articles might be clustered into topics such as technology, sports and finance based on their content. So what you can do is run the algorithm. It will find the different categories and update the articles with the new categories. So you can think of millions of such images and document in the computer, and how machine learning can help in text mining. So this helps in document categorization, search optimization, content recommendation, like this. So let's see this simple data set. So this is the data set. What it contains is annual income in the form of list and spending score. This is not a huge data set. I created this just to show you the basics. So annual income and spending score, then it comes in data frame, then k-means clustering like this, and you can choose the clusters, how many clusters you want to create, and the output, this, it will categorize like this, these dots. These dots should not overlap each other. So for example, if you see these dots and these dots, so these dots should not overlap this. This means there is you will face problems while working with that kind of data. So you have to change the algorithm and optimize it if you have overlapping data. So because I have not overlapped the data in this data set, this is the reason I'm not getting any problem. If I find the data set with the problem, I will show you. So just remember one thing, they should not overlap each other. Groups should not overlap each other. So these yellow dots should not be on top of this. There should be some gap between them. So for example, here it is, and then these yellow dots here, so not an issue, but they should not be. So for example, this dot, yellow dot, this dot, yellow dot, this, no, there will be a problem that you will face. So remember this, you have to clean up the data in that case. So unsupervised learning, this is how you look at it. So you have to first visualize the data and then add your own functionality to it. So what this was showing is, will show customers clustered into different groups based on their income and spending behavior. So based on their income and spending behavior. This will help businesses identify high spenders, average spenders or low budget customers. So based on that they can show the ads. So for example, showing the ads of, for example, sports car to everyone will be bad idea. So showing the helicopter ad to everyone will be bad idea. So first, businesses can use such things or techniques to identify kind of customers they are targeting to reduce the cost. So for example, if they find only 10,000 customers who can afford the helicopter, they will only show the ads to those. So this will help reduce the cost.
Sir, we have to give number of the cluster explicitly, right?
It depends, you can also automate that also, but in this example I have given this. So let's see, again I will show you this. It is clearly stating that you need to predefine it. I have automated this also in the past, but I will not confuse you with that. So this is what in most of the scenario is, you have to predefine how many clusters you want. It will keep doing it until it finds the, yes, see, no, you cannot remove n clusters entirely because it is mandatory parameters for the k-means algorithm to function. See, this is mandatory, and the algorithm will wouldn't know how to group your data. To determine, okay, so how to determine the best value? The point where the decrease in the distances sharply slow down. An elbow shape in the graph can indicate an appropriate number of clusters. See, this is elbow method. I think I have implemented it earlier. I will again try to implement it. So the chart will go like this, like elbow, and this score. This metric can be used to assess how well the clusters are for a given value. It ranges from -1 to 1, with higher values indicated better defined clusters. So this one will be the second technique. So there are techniques to find out what you have to put there. Yeah, by automating, what I means is, this is just a argument here 3. So what you can do is implement some algorithm here, and then pass one by one and plot the graphs, and check for this elbow and this score, silhouette score. These you can find. There are more techniques, there are more things, of course, but this is just the basic example. Can you remove n cluster? You cannot remove it, but you can change this based on the techniques that I have shared. Okay, so let's see the second one. I have already shown the chart, how it looks like. Python, this chart hierarchy. So let's see. Okay, so this chart hierarchy, you already know what hierarchy is. Simple. Now let's look at some real world examples. So the most important thing is real world example. They tell us how to use these things in real world. So what this clustering will do is arrange data into tree like structure, dendrogram. Based on their similarity, we can use it to find clusters at various levels of granularity. So what grains are? Smallest part of anything. Grains are smallest part. So it can show various small parts using this. So with its ability to organize data into tree-like structure, it is useful in many real-world scenarios where data naturally forms nested groups. Now let's move on to real-world example, biological taxonomy. So in biology, scientists study the evolutionary relationship between species. The goal is to classify organisms into hierarchy of taxonomic groups such as genus, family, and species based on genetic or physical similarities. Let's just look at the visual example. Okay, so this is how it looks like. Evolution. Let me show you this on big screen. Okay, so this is the example. Predictions about evolutionary patterns. Okay, so what it means is, if you have a data of evolution, so the data will be huge. So you already know, in creation of a human or homo sapiens that we are, it took millions of years. You already know that. So the data will be huge, so we will be dealing with large data set, and this will help to visualize the relationships. I have not implemented the code, but this is the example. I will continue this session in next video. See you in next video. Have a nice day.